Okay, this is a problem involving the SL model. What we are given is that a pump is raising the pressure from the inlet, let's call it state 1 to state 2. The pressures are given, and also it's given that in an isentropic manner. So what we know is that S2 must be equals S1. We have to ask to find delta T and delta H, the change in specific enthalpy and temperature. Okay, so let's first list what we know about state 1 and state 2. State 1, pressure is given. And let's assume the elevation is 0. Then state 2, what we know is 5 MPa, which is 5000 kPa. And isentropic, that means S2 must be equals S1. That's the key to the problem. Okay. So when you use the SL model, let's recall the formulas for property changes in the SL model. So we know that the entropy change delta S is given by CV ln T2 over T1. And if entropy doesn't change, delta S equals 0. So immediately we know that T2 must be equals T1. So therefore, delta T equals 0, a very trivial solution. Now, how do we find delta H? We know that delta H equals delta U plus PV. That's the definition of H, if you recall, which is delta U plus delta PV. And delta U, again, using the formula is CV T2 minus T1. And delta PV is what? V doesn't change, so therefore V can be taken out of the delta. It'll be P2 minus P1. Once again, T2 minus T1 is 0 because we already proved that T2 and T1 are equal. So the enthalpy change reduces to this. So all we need to do is what is the specific volume. Of course, we know specific volume is inverse of density, and it remains constant in the SL model. We know density of water is 1000 kg per meter cube, but to verify, we can always go to the tables, and where the SL model, if you go to the tables, the SL models are in table A, common solids and liquids. If you click there, you go to find liquids on the right side, water. Notice water is given at several different temperatures, different values are given, but generally it's a standard to assume water density to be, density is in the second column, notice, rho is in the second column, about 1000 kg per meter cube. It's assumed constant in the SL model. But here, variation of water density with temperature is given, but whatever value you pick, your answer will not vary much. So taking 1000, what we get is the other pencil, 5000 minus 100 divided by 1000, which turns out to be about 4.9 kilojoule per kg. Well, now how do you verify this solution using test?